All right, so now actually applying some stuff about reference angles for today. So we just wrapped up in the last video what is a reference angle and talked about how to find it in each of the 4 quadrants. So now we're actually going to do that. So what is the reference angle for the following angles? The easiest way to do this is to first of all draw it. Use your unit circle. It can help give you some guidance. So if I look at my unit circle, 135 is not one of the angle measurements on here. You see there's 120. There's 120 here, and then there's 135. So we're somewhere in between here. You don't have to draw a perfect picture, okay? It's just to help you. So, to draw my 130 degree angle, I know that it's somewhere over here, okay? If I just have to guesstimate based off of my unit circle. So that's 130 degrees. You now have a angle that's in the second quadrant, because again, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4 is usually how we refer to them. Quadrant 2, I go back up here, quadrant 2 says 180 minus theta equals the reference angle. So 180 minus my angle, which is 130, gives me 50 degrees. So this angle, let me do this part in blue, this angle right here, my reference angle, is 50 degrees. That would then be my answer. That's all you got to do on that. Same thing with 210. Again, you can look at your unit circle to get an idea of where it is. So if I go back over here to my unit circle, 210 is actually on it. Let me highlight it. Here's 210 down here. So I'm going to go ahead and draw that on my notes, just kind of as best as you can. Again, it does not have to be perfect. So 210... I know is somewhere, it opens up somewhere down here. So again, to find my reference angle in quadrant 3, I am looking between that terminal side and the x-axis. So I'm trying to find this angle, right there. So if I know this is 210, I look at my instructions for finding in quadrant 3, I know it's theta minus 180. That's what's written right here. So theta, which would be 210, minus 180, gives me 30. So that blue angle right here, that would be 30 degrees. That's my reference angle. That's all you gotta do for that. Just follow those instructions at the top and it should be good. Then on letter C, it says a reference angle is 45 degrees and its terminal side lies in quadrant 4. What are a possible positive measure and negative measure for the angle? Okay, so a reference angle is 45 degrees. That means it doesn't necessarily mean that's the actual angle measurement. It's just that terminal side through to the x-axis. So looking at what this is like. First of all, it says its terminal side is in quadrant 4. You know this is 1, this is 2, this is 3, because you go around counterclockwise, and this is 4. So my terminal side has to be down here, and this I know is 45 degrees. So, what's one positive measure and one negative measure for the angle? You can use your unit circle again for this. If this angle opened down, that would be negative, and it would just be a negative 45 degree angle. So I'm going to say a negative measure would be negative 45 degrees. Then for a positive measure, I'd have to open up and go the other way. So, around to here. To figure out that angle measurement, you can use this information at the top, 360 minus theta equals reference angle, to still solve it, okay? Now instead of knowing theta, I know the reference angle. So I'm going to say, to solve for the positive, 360 minus theta, because I don't know that, equals 45. Then to solve it, I can subtract 360 from both sides. I end up with negative theta equals negative 315, which means theta would equal 315 degrees. So this angle right here, when it's open positive, that would be 315 degrees. So there's my positive angle as well. Once you get better at these and you get more familiar with your unit circle too, you might even be able to just do that stuff in your head, and that's totally fine. Then this next part says, sketch each angle in standard position. So the first one says negative 130 degrees. So I start by drawing my coordinate plane always. Easiest thing to do is going to be using your unit circle, okay? You can also just kind of go by, once you get better at it, you can go by knowing this is 0, this is negative 90, this is negative 180, This is negative 270 when I'm talking about negative angles. So I already know negative 130 is somewhere between 180 and 90 over here in quadrant 3. However, if that's harder for you, you can always just look at your unit circle. So here's negative 135. Oops. Here's negative 135. Here's negative 120. I know negative 130 is somewhere in between. So I'm going to try to sketch that as best as I can in my actual notes. So somewhere down here, according to my unit circle, that would be negative 130 degrees. That's all you got to do on that. Now we're getting into radians. So all those pi measurements going around the outside, the green and the purple, those are something called radians, okay? This is a new concept for us. It's a different way of measuring angles, okay? So, looking at letter B, it says negative 5 pi over 6. Again, easiest thing is going to be to use your unit circle. Before I do that, I'm going to quickly draw my coordinate plane here, kind of. And kind of a general rule for doing radians is you always start with 0. Since I'm talking about a negative 1, I have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So pi is the same thing as 180 degrees, 2 pi is the same thing as 360 degrees, and the negatives just work in the opposite direction. Easiest way to think of this is just ignore the pi, okay? So if I start with 0, then down here I have negative 1/2, over here I have negative 1, over here I have negative 3/2, which is 1.5, and over here I have negative 2. That's not actually legit math, though, so I'm actually going to erase that from here. But that is an easy way to remember it. Just remove the pi from your head and think of it as being in halves, and it makes it easier. So if I look at my unit circle for negative 5 pi over 6, you can see negative 5 pi over 6 is right here. So I'm just going to draw that angle on my notes. I start with my terminal side, or my initial side, excuse me. My terminal side, as we saw in the unit circle, is somewhere over here. So this would be negative 5 pi over 6. Make sure you watch the video explaining what a radian is, because it's kind of like a conceptual thing that you need to understand, but here's the actual math behind it of how can you convert between radians and degrees. So take a look at example 4. This is pretty straightforward. Your book talks about 2 different equations. I just think that's confusing, and I think a lot of us like the math behind cross multiplication. I can tell because you guys always try to cross multiply on stuff. So I'm just going to give you one equation that works for everything. Here it is. You have r over pi equals d over 180. Okay? This is a proportion. Your radians over pi, okay, equals degree over 180. You are comparing pi to 180 degrees. If you look at your unit circle, you will notice right here, pi and 180 degrees are the same thing. That's why they're being compared. Then as you would suspect, r means radian and d means degree. Okay, so first of all, in letter B, it says convert the angle measure pi over 7 to degrees. So this is your r value, pi over 7. So I'm just going to plug that in for r, pi over 7 over pi, all right, that's the weird part, equals d over 180. The very first thing you should do when you're plugging in pi's, cancel them out. Whenever you have a pi over a pi, it cancels. So this cancels, and it does not change that to just 7, it changes it to 1 over 7, okay? And it changes this to just 1. So now what I'm going to do is, it's weird because you have a fraction and a fraction, but hopefully that makes sense. I'm going to cross multiply. So 1/7 times 180 equals 1 times d. Okay? Then you just got to plug in 1/7 times 180 into your calculator, which should give you about 25.71, and that's equal to d. Okay? 1d is just d. So you know pi over 7 radians is the same thing as 25.71 degrees. Then you can do the exact opposite. So converting the angle that measures 75 degrees to radians, now you know what d equals. So I leave r alone in the equation, equals my degrees, 75, over 180. It may be helpful to you right in this first step when you're plugging in a degree, reduce this fraction, okay? That will remove a lot of your stress. You can just plug it into your calculator. You could Google reduce 75 over 180 if you want to, or you can find their greatest common factor. In this case, that would be 15, okay? So if I divide 75 divided by 15, and I divide 180 divided by 15, 75 divided by 15 gives me 5, and 180 divided by 15 gives me 12. Okay, so that actually reduces to 5 over 12. So I have r over pi equals 5 over 12. Also, you can tell this is reduced now because they don't have anything in common. 5 and 12 have no common factors. 5 is prime, okay? And now you're going to end up with your answer in simplest form if you reduce it here. You can reduce it in the end, but this is just easier to reduce it from the beginning. Sometimes you won't have to reduce, okay? Sometimes you'll already have something that doesn't have to reduce down, but typically you will have to reduce. Now I cross multiply. So I have r times 12 equals 5 times pi, which we just write as 5 pi. And then to get r by itself, all I got to do is divide by 12. Do not simplify that anymore, okay? When we're talking about radians, you leave it in terms of pi, okay? Especially when you guys take like the ACT or whatever, everything's in terms of pi. You don't actually simplify anything down. So I'm just going to leave this as 5 pi over 12. And that's my answer. Make sure you watch the video explaining what a radian is. That will help this